Hope all of us are doing great. My name is Ernest. This is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at the concept of oxides of group 1 elements. And in this particular case, of course, this is going to compound on our first discussion we had on various compounds which are going to be obtained from group 1 elements, especially on the carbonates. Now, in our last discussion, I had mentioned that basically, if we try to look at the carbonates of, apart from the oxides, if you try to look at the carbonates of group 1 elements, we found out some of the unique properties are being displayed for the different compounds of group 1 elements. And one of them was a diagonal relationship which we had established for the carbonates of lithium and magnesium. And in that particular case, of course, we had seen that beryllium is going to exhibit diagonal relationship with aluminium in terms of their specific compounds, and boron is going to exhibit a diagonal relationship. Boron-carbon compounds are going to exhibit a diagonal relationship with, of course, a silicon. Now, in that particular case, we're going to look at the concept of oxides and try to see some of the unique characteristics which are going to be displayed by oxides of group 1 elements. Now, in this particular sense, then, therefore, we're going to see that, as we said, these basically are going to be alkali metals, which are going to form a group 1 elements. Now, these alkali metals are going to react rapidly with air or oxygen, and they are going to produce several ionic oxides. So in this case, I can just have a statement, an alkali metal reacting with air. Now, in this case, I've mentioned basically we're going to use oxygen. And this is going to form oxides, which are basically regarded as ionic oxides. Now, in this case, this is going to be a general description for the reaction of this particular alkali earth metals and, of course, air to form oxides. And we can give this one in terms of an equation whereby we're going to have either under a limited supply of oxygen, and then we are going to have under excess supply of oxygen. Now, in these two scenarios, we are going to have two different products in terms of oxides. Now, under the limited supply of oxygen, we are going to have, for instance, if I take lithium, we're going to have lithium react with oxygen to produce a lithium oxide. And this is going to be given as such. Now, there's going to be, in some cases, some of the products which are going to be formed are going to be varying. As we said, they are going to form a range of ionic oxides. Now, in this case, for the reaction of lithium, we're going to see that this is going to produce major and minor products, whereby the lithium oxide is going to be a major product, and then we're going to have what we refer to as a peroxide. And this basically is going to be lithium peroxide, which is going to be a minor product formed from this specific reaction. Now, as we're going to go on, we're going to see that there are different products which are going to be formed. Now, in this particular case for lithium, we're going to achieve this specific product. Now, under this case, of course, this was under the limited supply of air. Now, in this case, if we try to look at excess supply of air, we're also going to achieve other major and minor products. And for instance, we can take the case of sodium. Now, under, of course, excess supply of air, we are going to have a major product which is going to be formed. And this is a sodium peroxide given as that. And this is going to be a major product given. And then we shall have another product which is going to be formed, which is a minor product of this is specific product of sodium given as such. And this, of course, is going to be displayed by some of the compounds we're going to see, like the group 1 elements. Now, to react with other elements, of course, are given a range of, for instance, for potassium, rubidium, and cesium, there are some products which are going to be formed, which we are going to refer to as superoxides. So the reaction between the group 1 elements, which are potassium, rubidium, and cesium, are going to form superoxides. And we can give a general representation or an example of this using potassium. So if we have a potassium reacting with air, this is going to form superoxide, which is going to be given generally so that one. So some of the products which are going to be realized from these specific reactions are going to be relevant as well, as we said from our previous discussion on some of the applications which we are going to come across in our day-to-day lives. Now, in this case, if you look at the sodium, of course, which we have obtained in this specific case, sodium peroxide, and of course, this is specific lithium, which I've mentioned in this case, lithium peroxide. These are going to be a very essential elements, especially in trying to manufacture the bleaching agents in the, of course, detergent industry. So in this case, just to give this one, a summary form. So the oxides of group 1 elements are also going to form some of the essential compounds, like the sodium peroxide, which I've mentioned. And of course, we're going to have lithium peroxide, which are going to be forming powerful bleaching agents. And as I said, these are going to be used in trying to manufacture some of the products, or perhaps in detergent industry. And of course, as we're going to see that some of these products, especially for the peroxides, they're going to be used in devices, in submarines and spacecrafts. Submarines and spacecraft. And one of the common characteristics of this specific environment for this particular, of course, environment for this submarine and spacecraft is a limited supply of air. So we're going to see that one of the applications of these two specific compounds is, or the peroxides, is going to be the release of oxygen through a general relation which we can give in terms of this specific peroxide in reacting with carbon dioxide, and of course this is going to result in the formation of a metal carbonate plus oxygen being given as such. So this is going to be an essential part in the supply of oxygen in submarines and spacecraft, as we're going to see later. Now in this case, of course, the mentioned this is the specific compounds. Now this metal that we have given as M can be given as sodium or lithium given as such, and this is going to be one of the essential applications over these specific oxides of group 1 elements. Now there are various other oxides which we are going to look at, and of course that's going to form an essential part of some of a discussion on comparative study of various elements in terms of their reactions. Now in this particular discussion, I wanted us to appreciate some of the, of course, oxides which we are going to come across. And of course, one of the applications or the major applications in our day-to-day lives, especially in an industry or perhaps in our use, day-to-day use, perhaps in our domestic use, etc. So that is it for now, guys. Kindly check our description boxes for various links of other similar videos, and they are going to assist us in trying to understand the various applications and some of the useful compounds that we are going to obtain from the compounds of these different groups of elements down the periodic table and even across the various periods as we're going to analyze them. So that is it for now, guys. Bye, God bless you. Catch us in our next video.